Good morning. I am Dr. Huang. Today, I'm going to teach you a systematic method to write Lewis structures. This method is very powerful for molecules or ions whose Lewis structure is difficult to write. Here is a list of them. The example I'm going to use to illustrate this method is N2O. N2O is also called laughing gas. Before you start to write your Lewis structure, your instructor should give you a scalene structure. This is the scalene structure of N2O. A scalene structure tells you the connections between different atoms. An individual line in the scalene structure may not represent a single bond. This is different than Lewis structure. The first step to write Lewis structures is to place the valence electrons next to each atom. We should know that each nitrogen atom should have 5 valence electrons, and each oxygen atom should have 6 valence electrons. We will start from the nitrogen atom on the left, but I want to let you know, if you want, you can start from any atom. The nitrogen atom on the left has one neighbor. So, we will place one valence electron between the nitrogen atom and its neighbor. Then, we will divide the 4 valence electrons into 2 groups, or 2 pairs. When you divide your electrons into groups, each group can only have 1 or 2 electrons. You can place your electron pairs in almost any location next to the nitrogen atom. The only place you cannot put your electron pair is between the 2 nitrogen atoms. Now let's work on the central nitrogen atom. The central nitrogen atom has 2 neighbors. So we will need 1 valence electron between the central nitrogen atom and each neighbor. Then the 3 valence electrons left will be placed into 2 groups. 1 electron pair and 1 unpaired electron. Finally, we will work on the oxygen atom. The oxygen atom has 1 neighbor, so we will place 1 valence electron between the oxygen atom and its neighbor. Then the other 5 valence electrons will be placed into 3 groups, 2 electron pairs and 1 unpaired electron. I want to remind you, after this point, you cannot add additional electrons or take electrons away. But you're free to change the locations of the electrons. The second step to write Lewis structures is to change the locations of the valence electrons to make sure every atom will have an octet, which means every atom will have 8 octet electrons. Let me briefly explain how to count the total number of octet electrons. For the nitrogen atom on the left, it has 2 pairs of non-shared electrons. We also call them lone pair electrons. It has 1 pair of shared electrons. When we count the total number of octet electrons, we should include both the lone pair electrons and the shared electrons. The nitrogen atom on the left has 1, 2, 3, 4, 5, 6 octet electrons. The central nitrogen atom has 1, 2, 3, 4, 5, 6, 7 octet electrons. The oxygen atom has 1, 2, 3, 4, 5, 6, 7 octet electrons. As we can see here, none of them has octet. We have to increase the number of octet electrons for each atom. There are 2 ways, and only 2 ways, to increase the number of octet electrons. The first way is to share. To share means each atom will contribute an electron to form a shared pair. After forming a shared pair, each atom will have one more octet electron. When we look at the nitrogen atom on the left, it has 7 octet electrons. We still need to increase the number of octet electrons. If we want to form another pair of shared electrons, then the total number of octet electrons for the nitrogen atom on the left will be 8. This is what we wanted. But when we look at the central nitrogen atom, it will have 9 octet electrons. As we know, nitrogen atom can only have up to 8 octet electrons. So, to share will not work. We have to go backward. Then, we have to use the second method, to borrow. To borrow means one atom will borrow an electron from the nearest neighbor. By borrowing an electron, the nitrogen atom on the left will have -1 formal charge. The central nitrogen atom will have +1 formal charge. And then the total number of octet electrons will be 8 for the nitrogen atom on the left. The central nitrogen atom will have 7 octet electrons. The nitrogen atom on the left will be fine. Then look at the nitrogen atom in the center and the oxygen atom. Both of them have 7 octet electrons. If we want to share a pair of electrons between them, then the number of octet electrons for each atom will become 8. Right now, every atom will have octet. This will be the first Lewis structure we get from this method. But we want to replace the shared pair with a stick, which indicates it's a bond. The third step to write the Lewis structures is to find all possible resonance structures. If a molecule or ion has 2 or more bonds, and at least one bond is a double bond or a triple bond, there might be resonance structures exist. The Lewis structure we got from the previous step has 2 double bonds. Therefore, there might be resonance structures exist. To find all possible resonance structures, we should keep the relative positions of all atoms not changed. We should also keep the number of bonding pairs and the number of lone pairs not changed. To find all possible resonance structures, we can change the locations of the bonding pairs and the locations of the lone pairs. First, let's take away the formal charges. There are 2 more ways to place the bonding pairs. One way is to make the NO bond a triple bond. The other way is to make the NN bond a triple bond. Now we have to change the locations of the lone pairs to make sure every atom has octet. At the end, we will calculate the formal charges of all atoms in the 2 resonance structures we just found. The formal charge is equal to the number of valence electrons minus the number of lone pair electrons minus half of the bonding electrons. half of the bonding electrons equal to the number of bonds. For the oxygen atom, it has 6 valence electrons, minus 2 lone pair electrons, minus 3 bonds. So the formal charge is equal to plus 1. For the central nitrogen atom, it has 5 valence electrons, minus 4 bonds. It does not have any lone pair electrons, so the formal charge is plus 1. For the nitrogen atom on the left, it has 5 valence electrons, minus 6 lone pair electrons, minus 1 bond, equal to negative 2. So the formal charge for the nitrogen atom on the left is negative 2. The oxygen atom has 6 valence electrons, minus 6 lone pair electrons, minus 1 bond, equal to negative 1. So the formal charge for the oxygen atom is negative 1. For the central nitrogen atom, it has 5 valence electrons, minus 4 bonds. It does not have any unpaired electrons, so the formal charge for the central nitrogen atom is plus 1. Finally, the nitrogen atom on the left has 5 valence electrons, minus 2 lone pair electrons, minus 3 bonds, equal to 0. According to the rules of formal charges, the atom of a good Lewis structure can only have 0, plus 1, or negative 1 formal charges. Any other formal charges will make it a bad Lewis structure. Therefore, for N2O, we only have 2 good resonance structures. This is the final Lewis structure for N2O. It includes 2 resonance structures with a double arrow points to each other. It also labels all non-zero formal charges.